Hey guys, in this video we're going to learn about limiting reactants. But before we get to limiting reactants, let's look at what we've done so far with mole calculations. So far I've been giving you equations or chemical equations and asking you to predict how much of a product is created. In these problems, we've only focused on one reactant at a time. I haven't even told you how much of the other reactant is present. In these problems, the other reactant has been in excess. So what that means is that the other reactant is essentially unlimited. It's not going to run out during the reaction. Okay? But in this next section, we're going to look at what happens when we do have a limited amount of that other reactant. Okay, so in these problems, we're still going to predict how much of a product is created, but we're going to look at both reactants at the same time. So we are going to know the amounts of both things on the left side of the equation. Okay, one of these is going to run out first, right? The one that runs out first is called the limiting reactant. Right? And in these problems, we're going to abbreviate limiting reactant, LR for short. Right. Now, before we jump into an example with a calculation involving dimensional analysis and conversions, I'm going to give you a simple comparison, something that you can think about in real life and you don't really have to do math for. So, we're going to make grilled cheese sandwiches. Here is our recipe for grilled cheese sandwiches. We're going to use 3 slices of cheese and 2 slices of bread to make one sandwich. Now, in previous problems, I would just ask you, if I have this much cheese, how many sandwiches can I make? Or if I have this much bread, how many sandwiches can I make? We're going to look at both together. So these are the supplies that we have. If you have this at your house and you want to make sandwiches, right? How many can you make? So we need to look at how much can be produced from each different ingredient in our recipe. Okay, so if we have 12 slices of cheese, that's enough slices of cheese to make 4 sandwiches for us. And if we have 6 slices of bread, it's enough to make 3 sandwiches. All right. When we consider both of these reactants in the equation together, we're going to run out of one before we run out of the other. Okay. We can see really easily that our bread here is going to limit the amount of sandwiches we can make. We only have enough bread to make 3 sandwiches. Even though we have enough cheese, right, we're going to run out of that before we get to 4 sandwiches. So we end up with only 3 grilled cheese sandwiches in this example. So bread is our limiting reactant here. All right, so just an easy comparison you can see in your head. All right, now let's move on to an example problem where we have some conversions. All right, so this is the chemical equation we're going to work with. It is the combustion of methane. 1 CH4 plus 2 O2 gives us 1 CO2 and 2 H2O. My question here is, if you have 20 grams of CH4 and 30 grams of O2, how much H2O can you produce? So this problem's a little bit different because I gave you 2 amounts for the reactants. CH4 is limited to 20 grams and O2 is limited to 30 grams. Just like the grilled cheese sandwiches, we're going to see which ingredient runs out first when we're trying to make H2O. Okay? So step 1 is pick our product that we're going to solve for. This question asks you for H2O, so we're going to use H2O. Step 2, we're going to pick a reactant to start with. Let's start with CH4. So we want to know how many grams of H2O are going to be produced by 20 grams of CH4. All right, so this is going to be a conversion problem just like all the others. Right? I have my conversion factors already lined up here. We need a molar mass for each of our formulas and a molar ratio. Our goal unit is grams of H2O, and our start from the problem is 20 grams CH4. So we're going to line up our conversion factors till we cancel out grams of CH4 and get grams of H2O at the end. We're going to start with the molar mass for CH4, making sure that the grams part of the conversion factor goes on the bottom. And that gives us the moles up top. Grams of CH4 cancels out. We can then switch over from our formula of CH4 to our goal formula of H2O. Right, we use this conversion factor. We're going to use this molar ratio now. CH4 goes on the bottom and H2O goes up top. And next, our final conversion factor will be our molar mass to get from moles of H2O to grams of H2O. So I put moles on the bottom and grams up top. Alright, so moles CH4 canceled out, moles H2O will cancel out. We're left with grams of H2O, that is our goal formula. And once we plug all this into the calculator, our answer is 44.956 grams of H2O. Okay, so this is how much we can produce from that amount of CH4. Alright, so our next step here is to go with our next reactant. So that reactant is oxygen. I have 30 grams of O2. I want to find out how much H2O I can make from that. Again, I need a conversion chart. I have all my conversion factors lined up already. My goal is the same as the other one, grams of H2O. But this time I'm starting with 30 grams of O2. Okay. Again, I have 2 molar masses and a molar ratio. I'm going to use my molar mass for O2 first. This will switch me into moles of H2O. I'm sorry, moles of O2. My molar ratio to get from O2 to H2O. And then finally, I'm going to use my molar mass for water, which is the same from the last problem, to get from moles of H2O to grams of H2O. Grams of O2 cancels out, moles of O2 cancels out, moles of H2O cancels out, and I have grams of H2O. When I plug all this into the calculator, I get 16.890 grams of H2O. Okay, so I now have the 2 amounts of H2O that I can create from my amount of reactants. All right, so step number 6, I'm going to compare those 2 amounts. From the 20 grams of CH4, I was able to make 44.956 grams. And from the 30 grams of O2, I was able to make 16.890 grams, okay, of H2O. Both of these are H2O. Okay. When we compare these two, we're looking for the lower number. Okay, so this is our lower number of H2O produced here. This is going to be our LR. Okay, so O2 is the limiting reactant in this problem.